All right, so here's a system of three equations, three unknowns. We want to solve this. Step one, we need to determine which variable it is that we want to eliminate. Now, if we go back through your four steps, I had said to look out for freebies. Look for an equation where there's already a variable missing. So I want to point out what's going on here is that we do have a variable missing there. We also have a variable that's already missing there, meaning the smart choices for which variable to eliminate are either going to be x or z. We're not going to eliminate y because it's not a freebie. Even though it might not be hard to eliminate the y's, it's not free, and free is always better than easy. So we're going to pick either x and z. To determine which one we should do, what I would suggest doing is looking at the remaining x's and the remaining z's and see how hard would it be to use the addition method to get rid of them again. So as far as the x's are concerned, I'm going to look at the remaining 7x and x and say, yeah, that's not too horrible. I'd have to probably multiply by -7 in the second equation, and that would get them to line up nicely. But if I compare that to my z's, they're already set up to eliminate. So it looks like there is a smartest one here. And big picture here, always take a minute to make a plan up front. If you can save yourself work in the long run by planning your work out smart, you're going to be happy with yourself. So we're going to make a note to ourselves. You have a spot in your notes for this, but I'm always going to write it down that we are going to eliminate z. It's important to write this down somewhere. Now, also as far as your organization, you're always going to make yourself a note that you're looking for two equations. I like to use a little bracket here if you want to use braces or whatever. It doesn't matter. Make some sort of notation that your goal is to end up getting two equations that are both missing z. Now, what I like to do personally as far as organizing my work is I like to keep the flow of the problem in one column here. So this is the flow of the problem. And then off to the side over here is my scrap. That's how I like to organize my work. And if I organize it the same way every time, then I'm not going to get lost in my problem and say, where am I at again? Also, if I make errors, it's easy to go back and follow my work and say, all right, where to make an error? And I can actually follow step by step by step. So I always follow the same pattern, and this is the pattern, and I'd advise doing it. So as far as the flow of the problem, these are our main steps where we say, all right, I'm supposed to eliminate z. I'm going to take my freebie first. I'm going to copy down equation 1. So copying down equation 1, that's one of my equations that's missing z. My goal is to get two equations missing z. So the next thing I need to do is eliminate the z's in a different way, which is going to happen from adding those two together. So off to the side in my scrap paper land, I'm going to rewrite that equation, and when I add them together, what am I going to get? I'm going to get x minus 3y equals 5. And I'm going to copy this over into the flow of my problem. And I'm going to pause for a second here. If we look back to our four steps, we have now determined which variable to eliminate. That was step 1. We've now eliminated that variable in two different ways. So if we look at where we're at now in this problem, what we've already accomplished is the only new thing to this entire lesson. So if we look at this right now, we can say, hold on a second. We've done problems like this before. This was last lesson. This is two equations, two unknowns. I know how to handle this. I'm going to multiply by -7. So I'm going to copy down the first equation there. But then if I multiply by -7, I get -7x. 21y equals -35. I add these guys together. That gets me 25y equals -25, or y equals -1. Now, I need to continue solving my two equation, two unknown system. So what I mean by that is my eyes are still here. I'm ignoring everything else. I'm ignoring the work on the right. I'm ignoring the original problem. I'm focused on getting my two answers to the system of two equations, two unknowns. So what I'm going to do is I'm going to take that answer of y equals -1, and I'm going to plug that back into the blue equation there. That's going to get me x minus 3 times y equals 5, or x plus 3 equals 5, or x equals 2. So as far as our 4 steps, we're now done with step 3. We've finished solving the two equation, two unknown system. So now that we have this, now we can figure out what z is. So we look back to the original problem and we look for one of the equations that has a z in it. Doesn't matter which one, and we're going to plug back into that. So if I plug back into the equation that has z in it, that would be y minus 2z equals -1. If I add the 1 to the other side and then divide by -2, I find that z is 0. Now to write my final answer, the order matters because it is an ordered triplet. I'm going to have my x value, followed by my y value, followed by my z value. And that's the final answer to this question.